Okay, on to the next page. We have fill in the blanks and graph each quadratic function, plot at least 5 points or as many that will fit on the graph. So the first page was in vertex form, now we're in standard form. So if we have x squared minus 2x minus 8, I'm going to start out by saying a is what? A is what's in the front, so we have 1. B is our middle term, which is negative 2. And C is the last term, the constant, and that's negative 8. So this opens up because A is positive. The equation for the axis of symmetry, that will be an x equals, but to figure out what it's equal to, we're going to do x equals negative b over 2a. So we'll have negative of negative 2 is positive 2, and then 2 times a, which is just 2, so that equals 1. So my equation is x equals 1. Now once we know what the axis of symmetry is, because that goes through the vertex, that is the same value as our x value for the vertex. To figure out the y value, we have to take that x value and plug it in. So we'll have 1 squared minus 2 times 1 minus 8. So I'll have 1 minus 2 minus 8, and that's negative 9. So my vertex is at 1, negative 9. So that negative 9 is also shared as either a maximum or minimum value. And because this opens up, this graph has a minimum value of negative 9. The y-intercept always has an x value of 0, and the y value is c, so c here is negative 8. So our y-intercept is 0, negative 8. And the x-intercepts we'll get from our graph in just a minute. So we have the vertex of 1, negative 9, and as it turns out, that point is just slightly off the screen. But we can still use the 1, 3, 5 like we did before. So we have 1, 3, 5. And we're still going to multiply it by the number that's all the way in the front, the a. Well, here it's just 1, so we're just going to still do 1, 3, 5. So from our vertex, we'll go out 1, up 1. Then we'll go out 1, up 1, 2, 3. And the next time we go out 1, up 1, 2, 3, 4, 5. And just so you know, the pattern does keep going 1, 3, 5, 7. So if I went out 1, I go up 7. Okay, so let me connect all of my points. Okay. So the x-intercepts are at negative 2, 0 and 1, 2, 3, 4, 0. Okay, number 8, we have negative 2x squared minus 4x plus 6. So again, I'm going to list out what a and b and c are. A is what's in front of the x squared, so we have negative 2. B is the middle term that's in front of the x, so we just have minus 4, and then C is 6. So this graph opens down because A is negative. The equation for the axis of symmetry is x equals, please do not forget that part, I will count off if you do not include the x equals. So if we have negative b over 2a, so we'll have negative of negative 4 over 2 times a, which is negative 2. So that's 4 over negative 4, and that equals negative 1. So here we have x equals negative 1. Because we know that x value, we're going to put that here at negative 1. For the y value, we plug in negative 1, so we'll have negative 2 times negative 1 squared minus 4 times negative 1 plus 6. And we get positive 8. Negative 1 squared is positive 1. So 1 times negative 2 is negative 2. Negative 4 times negative 1 is positive 4, and then plus 6. So that's 10 minus 2 is 8. So now that we know that 8 is the value, we can put that here in that blank. That is the maximum value. It's a maximum because it opens down. The maximum value is 8. The y-intercept, x value of 0, and this should be equal to c, which is 6. And we'll get the x-intercepts in just one moment. So let's graph it first. We have the vertex at -1, 8. I'm sorry, -1, +8. I was counting down. Okay, sorry, my mistake. So -1, +8. The 135 is being multiplied by a, which is -2. What's all the way in the front? So we'll have -2, -6, and -10. So when I go out 1, I'll go down 2. Out 1, down 1, 2, 3, 4, 5, 6. And that's as much that will fit on there because we can't really go down 10 without going off the graph. So our x-intercepts are 1, 2, -3, 0, and 1, 0. Okay, so now we're going to work on quadratic regression. The data table shows the energy E of a certain object in joules at a given velocity v in meters per second. So here's our table with velocity and energy. So first, we need to find the regression equation E in terms of v rounded to the hundredths place. So to do that, let's switch over to the calculator. Okay, so you've got your calculator, and you'll see the keypad on the left and the screen on the right. So what we're going to do in order to get the equation for this is we're going to go into a new document. If it asks you to save, say no. And first, we need to put in the data, so we need to add lists and spreadsheets. So I'm going to call this X, and I'm going to call this Y. You could call it V and E if you like, but I'm just going to go with X and Y. And I'm just going to type in my values. Now that I have my values typed in, and make sure you've got your columns labeled and all of your values are entered, I'm going to add a new page. So I'm going to go to Control, Doc, because above Doc it says plus page, and I'm going to add data and statistics. So you'll get some kind of dots all over your screen. So at the bottom I'll click and choose X, and on the left I'll click and choose Y, and you can kind of see the curve of a parabola there. So of course all we're working on is quadratic, so we're going to go to Menu, Analyze, Regression, and Show Quadratic. And you can see here that we've got our equation, y equals, and the quiz or the review sheet asks for you to round to the hundredths place, so 2 decimal places. So let's switch back over to the worksheet. So we're going to round to 2 decimal places, so that means we'll get, if you're writing the equation E in terms of V, then you'll get E equals 2.28 V squared minus 1.64 V plus 1.98. Okay, so number 10. What is the energy of an object with a velocity of 5 meters per second rounded to the hundredths place? So if it has a velocity of 5 meters per second, that's what we're going to plug in for V, or if you used X and Y, you would plug it in for X. So I'm going to go back over to my calculator, and because I've got my equation already written down, I'm going to go to Control Doc, and I'm just going to add a calculator so that I can plug this in. So I'm going to plug in 5 into the equation. And I get 50.78. So the energy of an object with a velocity of 5 meters per second is 50.78 and then joules. Okay, number 11 and 12, it says state the domain of this function. Because it says function, and because this is what I had gone with, just so you know, if you speak to another teacher, they will probably say something else, and this is just something that I had done on my part. If it says the domain of this function, I'm actually wanting us to say the domain of this function that we wrote on number 9 outside of the situation. More than likely, if you are a student from another teacher, not of Miss Suderman's, then you are going to write the domain of this function in a real life situation. But because my classes, it was the domain of the whole function, we'll say all real numbers. And then for the range, to state the range of this whole function, let's switch back over to the calculator. So we need a picture of the whole graph. So I'm going to add a page, added by pressing Control Dock. I'm going to add a graph. And so I've got 2.28. And here we need to use x instead of v because the calculator understands x. So 2.28 x squared minus 1.64x plus 1.98. So there's the graph. And for the range, I'm going to need this information about the vertex. You've got two options. One of which is to go to Menu, Trace, Graph Trace. And you'll see these little crosshairs come up. And if you hit the left and the right arrows, if you go to the vertex, it will say here's the minimum, and you'll see in the bottom right hand corner that our smallest y value is 1.69. Another way you could do it is by going to Menu, Analyze Minimum, because this graph is opening up, and then click on the left and the right side of the vertex, and again you'll get the same information, 1.69. Therefore, the range is y is greater than or equal to 1.69.